welcome to all of you. We're so delighted to have you all here. And for Flipping Calculus, which is going to be very interesting. I'm not going to give away their thunder by explaining what we mean by flipping. For those of you who are not familiar with the term, I'll leave that to our presenters. But we have 4 very distinguished presenters from the College of Arts and Science, Department of Mathematics, most of whom who have been experimenting with using and integrating technology into their instruction for many years, and most of them have been working with FCLD on and off, either in a capacity of grants or of just disseminating ideas about ways that they can use technology and make more effective instruction. So I'm going to do a quick introduction, but then they will kind of explain the concept, and I'd like to thank them for their contributions here. First, John Williams, who's an Associate Professor and Chair of the Mathematics Department in Arts and Science. And John and I were just chatting. He had got his PhD from Indiana University, which I didn't know. I also attended Indiana. And he's been exploring, like I said, the integration of technology and teaching math for many years, and received several grants from the Provost's office for this. His academic career started in complex variables. Did I get that right?
That is correct.
And, but the Beaver-Bach conjecture, which was just solved when he graduated from Indiana, remains one of the focus of his interests mathematically. I didn't ask him what that is. I have no idea. You can ask him afterwards. We also have Professor Ray McGivney. Ray received his PhD from Lehigh University after receiving his master's and bachelor's from Clark. And Ray has been working with us for so many years, and I keep thinking, is he going to retire? And he says, no, we don't, I'm not going to retire, which I think is wonderful. But he has been exploring a variety of ways to integrate technology into math instruction, and a delight to work with him. His focus on teaching is so very visible and very inspirational to all of us at FCLD. Jean McGivney-Burrell, who is, I think, about to, this summer, taking on a new role as, tell me if I'm wrong, Director of Secondary Mathematics Education with the NHP.
I've been Director of Secondary Mathematics, Chair of Education.
You're going to be the chair. We had that debate, and I was like, I thought it was going to be the chair. So anyway, she'll be chair. So she'll be leading the mathematics, or you're going to do a
I'm going to do both.
You're going to do both. And her interest is in the use of technology to improve teaching and learning of mathematics. She received her degrees in mathematics at Northeastern and the University of Hartford, and got her PhD from UConn. And finally, we have Fei Xu, who goes by Professor X, he tells me, and his research specialties are difference and differential equations, as well as a new area called dynamic equations on timescales. He received his bachelor's degree from South China University of Technology, and then earned his PhD from West Virginia University. So thank you all very much. We're looking forward to this. And I understand that you received a grant on this work through the Provost's office. The Provost had put out a call for large-scale grant money for developing technology, integrated technology solutions. And I believe that they're going to be developing that for the fall. Are you starting now?
Yes.
So maybe you'll probably be talking about that as well. Anyway, thank you all. We're delighted to have you.
Thank you. Introduction.
Okay, we hope that this is informative. Wow. We want to make this informal. We have a structured presentation, but feel free to stop us at any time to ask us any questions you might have as we go, okay? I'm here to do just a very brief overview of flipping and to set the stage for what's to come next. How many of you know what a flipped classroom is? Okay, I would say virtually everybody, right? So quickly, we're just inverting instruction. We take what typically happens in class and move it outside of class. So think of lecturing, maybe some reading. All of that gets moved outside of class, and then we take things that happen outside of class, typically like homework and problem solving, and move that into class. Okay? So that's what we mean by a flipped classroom. If you look on the web, there's all different interpretations and structures for a flipped classroom. The way we have designed our flipped courses is through the following series of components or events. The way it works right now is we are creating brief videotaped lectures and worked examples and posting them online. We provide some sort of assessment that the students are actually doing, watching those videos ahead of time, and that could either be through an online quiz, or in some cases we're doing short quizzes at the beginning of class, and then the whole structure of the class cooperative group work or problem solving. We originally got hooked on this idea when we attended a session that RJ's office, University Studies, thank you, hosted back in the fall. Chrysanth Dimitri is a mechanical engineering professor at WPI, and she's done some work in flipping her large lecture classes at WPI. And some of the lessons she learned from it is that students gave her very positive feedback on the work they were doing in class. They much preferred to be spending time in class working on problems than listening to a lecture. And she also noticed that the students in the flipped classes were spending more time even outside of class learning the material. So we were encouraged by that. At the same time, we were having discussions across the math department about our calculus class, and some of us were giving course evaluations to our students, asking them to give us feedback about how things were going. And a consistent theme in several of our courses was that students wanted more time in class solving problems with the instructor there to support their learning of the material. Around the same time, students were starting to come to us and talk to us about videos they were watching outside of class that we had not posted because we hadn't started flipping yet. A couple of our students had heard about Khan Academy. Have you heard of Khan Academy? So Khan Academy has been offering free mathematical videos for some time now, and students were going on their own and finding these videos themselves to reinforce their understanding of the mathematics that was being presented in class, and they talked about how helpful those videos were. So all of this taken together, plus our emphasis in the math department trying to improve student engagement in the class. Ray calls it working towards 100-100, that is getting 100 students, 100% of the students paying attention 100% of the time. And so everything seemed to sort of coalesce at the same time, and we decided that this would be the next step in trying to make our calculus classes, and even our more advanced classes, as Ray's going to talk about in just a minute, more engaging for the students who were sitting in those classes. So our structure for today is Ray's going to talk a little bit about what he did in Math 222W, which is one of our sophomore level math classes. Then Faye's going to talk about his work. He actually did an exploratory study comparing a flipped section with a non-flipped section of his course. And then Dr. Williams is going to talk about where we're headed next with our flipping.
I'm Larissa Schroeder today, by the way. She's at a conference that Larissa was going to do, because she's doing some flipping in class as well. Yeah, this class, here's what I'm going to talk about. Give you an idea what a typical class looks like. A 100-minute class, here's what I do twice a week. Then I'll tell you what the students have told me they think about flipping. And then their comments on the videos, because they're two related topics. The video is part of the flipping process. And then give you my impressions of these last 12 weeks. Because I've done it almost all semester. I've done about 12 videos. And so I've got a fairly good sense of where the kids are, where I am with this course. And these are impressions, by the way. I'm learning all the time, as nothing's set in stone. And this is the University of Hartford edition of flipping. I'm sure it varies from school to school to school. So I'll tell you what my impressions have been so far, and then maybe talk a little bit about the videos per se. We weren't going to talk a lot about videos because you have sessions on Echo too, but we may show a video at the end if we can stand and watch the math video for a few minutes. Okay, so here's a typical class. I've got 16 students in a 200 level class. They're mostly majors, some CS kids thrown in and a couple of physics majors. So it's a nice group, 16 kids. Where do we begin? Every class is a 10-minute quiz as soon as they walk in the door. That's all that matters. The quiz is on the board, and it's on the assigned video. So at least a week ahead of time, I've posted on Blackboard, here's the video, here's the date, come to class, make sure you read it, I watched it, and we'll take a 10-minute quiz as soon as we begin. Okay, so that's absolute every single day. I've tried giving 2 videos on a class and then a double quiz. It doesn't work so well. The limit seems to be 10 minutes is what they want to watch and get tested on one thing. So that's where we've stayed pretty much close to. What am I looking for in the quiz? I'm not looking that they master the material, obviously. I want them to be familiar, that they've got some idea of what the basic terms are involved, and that it has some punch to it, so I'm going to count it 10% of their grades. If they come in prepared, at least to begin a discussion. Mathematics, almost every topic we deal with begins with definitions. From the definitions, some examples, and then we work our way up to theorems. But you've got to have that definition really solidly in your mind. There's no way around it. So this is a first brush. They memorize it now, and then in each level we hope that not only can you memorize it, can you apply it to simple computational problems, then can you prove some theorems. That's sort of the chain we're trying to go up all the time. So this is the beginning, and what it really helps is to go over the quiz immediately, because then all of a sudden some misconceptions come to the surface right off the bat. Oh, I didn't know that's quite what the definition meant. I wasn't sure that example in the video. Now I see clearer what the purpose is. And what it does, of course, is it gives me a springboard into the class too, because now you've re-emphasized what the definition is, and now you can launch into the class. Now this is optional next. Sometimes I'll just give them a problem sheet with 7 or 8 problems and say, off you go. But sometimes I don't feel I've bridged the gap between the video and what they have to do on the problem sheet, so I'll spend some time. I'll do another couple of examples, maybe prove a theorem and so forth. So this is somewhat optional what I'll do next week for the next 10 or 15 minutes. I'm going to come back and say something about that. And then we hand out the worksheet, 8 to 10 problems, and they work in groups.
I'm just curious with the quizzes.
Yeah.
I'm guessing then there's no makeup?
No makeup.
So they
I drop the lowest, I tell them.
Right.
But no, there's no makeup. They got to be there. Right. Yeah. And they have been. I mean, the attendance has been terrific for class, so that's not an issue. Yeah. The average quiz grade is 85. I mean, with dropping 1 quiz. So, I mean, it's not as though they're suffering from this. And,
no, I wouldn't expect, but
and I can keep track of who watches it when, too. You can track this on Blackboard, so that helps. They tell me most of the kids seem to watch it twice. They'll watch it maybe the night before, they'll watch it 10 minutes before class. You know, just to hold it in there, you know, just to get it out. Yeah. I don't assign you reading. This is the reading, is the video. That's what it's become.
And is the video, does it have problems that they have to do as well?
No, it is generally this. It's generally a definition and a worked out example. And that takes 10 minutes to do that.
Oh, absolutely.
You know, it takes 10 minutes. Some kids want me to start doing theorems in it too. In other words, take the definition, take an example, and then prove a theorem with it. Well, we're going to be talking 15 minutes if I do that. I'm not sure that's the way to go. They also suggested maybe I create some other videos of worked out problems that are not part of the quiz, but they're there for the kids to go use them if I want. That's another possibility I might be doing. Yeah. But for the time being, this is really pure vanilla. This is definitions, some examples, and gets us on. And then the worksheet, and the worksheet's graded from computational problems into a little more difficult problems into theorems, into conjectures. Big thing in mathematics is here's a statement. Is it true or false? If it's true, prove it. If it's false, give a counterexample. That's what mathematical research is all about, basically. So we're trying to get the kids into that. So several of the problems near the end will be these pure conjectures the kids have to try to resolve with the conjectures. But computational examples, dimension theorems, and a whole range of things. So they work on the worksheet. It's not graded during class. I don't grade it. I go around and just see how you're doing. They don't seem to want it to be graded. That's not a big issue with them. They want to know if they're on the right track with these problems, what they're not understanding about the problem. That's what they're using this time for. And I circulate. I get around. Not everybody's in a group. As try as you will, you can't force everybody in there. So I've got probably 12 of the 16 working groups and 4 singletons. Of the 4 singletons, 3 are very, very good students, and 1 is not so good. And I can spend more time with students not doing so well, who seem to be getting along fine by themselves. But I get along, each group, I must get 3 or 4 times at least in 100 minutes to see what's going on. Sometimes the groups will morph. You have one group turning around and getting together with another group because they get a sense the other group's onto something. And that's fine. I mean, it's a relatively relaxed, loose classroom that way, obviously, because kids are working at their own pace and own speed. Sometimes I'll stop halfway through and give a mini lecture. It's clear that something's not quite clear. I'll call time out and say, all right, let's hold it for a second. Let me go up to the board and try to clarify a couple of points that are going on. And then sometimes students come up and write on my tablet when they get solutions, because they like to leave with a complete set of solutions to these problems as much as possible. So I have the tablet. I do all my work on a tablet, and they'll come up and they'll write their solutions, and then I'll post the solutions as we do them throughout the class. I sort of do them on the fly. So we leave with almost all the problems done, and what I'll do after class is go back and write solutions for the remaining problems, and then post those notes. So they have a complete set of solutions for all of the worksheet problems. I thought I'd run out of problems. I worry about the good kids going too fast, but so far that hasn't been the case. Everybody's worked for the time, and so far that I've seemed to be able to gauge how much I can expect in the 15-20 minutes that we, in the 50 to 75 minutes we have. Post the notes and then assign homework. I mean, there still is homework in this. So it's not as though they're doing all their homework in class. what they do in class is getting ready to do the homework that is assigned for the next class. Now, the only thing I'm going to change in this, I just got results of 17 surveys back yesterday, last night. I spent 2 hours going through the surveys about what the kids feel about the course. Believe it or not, this is interesting. What they feel I ought to do more is more lecturing. You know, I thought they'd want to do more working on the problems. Because it used to be all lecture, and now we're moving over to more and more problem solving. But they're saying, no, that's too much for 90 minutes. We need you to break it up a little bit here. So what I'm going to do now, this is not going to be so optional. I'll give the quiz, then I am going to do some leading off and bridge work with another example, try to flesh it out in more detail. And then have them work on 2 or 3 problems. And then about halfway through the class, come back and do a little more lecturing, and then give them another set of 2 or 3 problems. So I'm going to break it up, lecture, problems, lecture, problems. I think bite size is going to work a little bit better that way. So, yes.
I have 2 questions on your last 2 points.
Yeah.
What is in the notes if they're doing problem stuff all the time? And
Yeah.
how much is the homework work if they're...
Homework is worth 30% of the grade. The test is 60%. Homework is 30%. They can revise the homework. It's due for a certain day. I pass it back the next day. They can turn it in the very next day. So, I usually drop 1 or 2 homework grades. We've got 16 homework grades. We'll have 20 before the end of the semester. So that's 60% of the grade budget.
How would it work with the 116 students? So the 200 are pretty serious students.
Yeah, I don't know. That's a good question. I
Math
used
116 is the first, or for non-math majors, correct?
Yeah, I have. These guys are more homogeneous in terms of their ability and background. The 116 kids are all over the place, and I think I'd have a hard time developing problem sets that would keep them active. I'm into this because of engagement with the kids, right? I mean, I think all of us are. I don't know, as teachers, I don't feel good in the classroom if I feel there's a vacuum, a denseness, that nothing's happening there. So the way I solved the problem in 116 was with the clickers. That works pretty well there because these kids in that class need to be stimulated on a more frequent basis, I think, and the topic is different. I could not make the clickers work so far in this advanced course. I just don't seem to have the right questions to make it work. That's why this device of using the videos and the problem set seems natural to the upper level class more than the freshman level. Question?
No, comment. I was just sort of reflecting on what you're doing and what I used to do, and I think I took what would have been your 116 and I
Yes.
modified it for my high school classes
Yes.
when I was doing that.
Yes.
And basically I operated, they were in a computer lab because that's what else I
Yes.
was teaching. So they were sitting at their
Yes.
computers using Excel to do most of
Yes.
their problem sets, and I just had them working in class. So maybe 5-10 minutes of lecture at the beginning of a
Yeah.
class, and then they worked the rest of the time, and then for like 2-3 days. And
When you had the computers in front of you, you had something, actually, a device there to help them do that.
yeah, because a lot of it, you could either have done it with a calculator or in Excel,
Right.
and it worked out fine.
Yeah.
No.
Yeah. Well, again, the bottom line is getting the kids active for that period of time.
Oh yeah, that worked very well.
Is this okay? Let me give you a rough idea of what I do. Yeah, please, Ryan.
Are you assigning basically the same homework you have in the past, or do you find you're assigning less or different types of homework?
About the same types. I'm covering about the same material for the course. I'm assigning about the same problems, maybe a little bit more problems. They tend to simulate what I've done in class, maybe pushing things a bit further. So my homework is, I'd say the same vein of what they're doing in class.
So their total out-of-class commitment is a little bit more now because they've got the same homework basically plus this video in advance.
They've got to watch the video, plus they do the homework there. Yeah, years ago I'd lecture and give the homework assignment.
Right.
Now they're doing problems in class, but they're still, so they're doing more problems because they're doing problems in class.
Right.
That's what's happening, and that's good. The more the better in this case. Okay, is that clear? I mean, roughly, yeah,
If
please.
you do it at the beginning of the class, is there any problems on that, or is it just strictly the definitions because that's what the video is?
It's based on the video, so it's almost invariable. I'll ask, what's the definition? I'll give them the
Yeah.
definition.
But then are there problems too, like following the problem that you worked out?
Yeah, there's one more problem that is somewhat parallel to the one I gave in the video. At first, I made it really vanilla. I gave the first one, I think, was just exactly what was on the video. Now, I've started to move it up a little bit. I don't want to go too far, because I don't want this to be a destroying experience. This should be a pumping experience that I'm up to. But I got to be careful. Sometimes I want to try to push them a little bit more in time. So far, it seems to be manageable. Yeah. I mean, it's all touch. All that stuff. You know, it's all just touch as you go. Okay, here's what the kids tell me about flipping. Obviously, you can watch the video as many times as you want. I called my 95-year-old mother the other day and told her what I was doing. and explaining these videos with kids outside of class, and she said, "You mean they can watch them twice?" And I said, "Yeah." She said, "Oh, that's good. I like that." 95-year-old grandmothers and mothers can't be wrong. So they can pause and read. They say this all the time. It's there. It's on file. They can go back and even use it for tests. Some of the kids for tests, I go back and rewind. Take notes at your own pace. Sometimes I'll have complicated diagrams on there. They don't have to worry about rushing to get the diagram down. They can get the gist of the lecture and go back and copy the diagram if they want. These are their comments, by the way. This is not my answer. This is what they're telling me. We're using class time better. That's what they feel. We're using class time better. Now, not 100%. There are some kids in the surveys suggest that they like the lecture. I mean, I don't know whether they just feel that they've been so used to being told information they want to have a telephone. That's not the case, but the majority of the kids like the film. In that survey I had yesterday. What the video does is what? Give them previews. It's a trailer. What kind of a trailer? It gives them the beginning of what's coming in to the next class. Gives them some idea of the basic thing that they've got to know. The nugget. We talk about nuggets in our department. You're teaching a course for a given day. What is it that you want the kids to walk away from that class knowing? That's the nugget for the day. And the nuggets usually begin with the definitions. You see the definitions again and again and again. Problem solving, improving fairness. You know, they think they have the idea of a definition and they can memorize it, but they haven't got their arms around it. So quiz gives a running start to class because we go over the definition, boom, now we're right into the class doing some problems. The worksheets give a running start to the homework. Misunderstandings, they tell me, can be addressed immediately instead of going home being frustrated about the problems. I don't know which way to turn, I don't know what I'm doing wrong. That can, a lot of that can be cleared up in class now. And so those are the main things that they told me earlier in the semester. I think those are still true. Okay, about the videos, they tell me this too. This is student comments, 10 minutes max. I guess there's literature that suggests that. I mean, I'm sort of scared to think I've taught 46 years and most of that time I've lectured. And they haven't heard a word I've said after the first 10 minutes, which means about 85% of my career is down the drain. They like bookends on the videos. They like a word or two about what you're going to do. You know, it's the old tell them what you're going to tell them, and then tell them that you told them, right? They like a little bit at the beginning about what is it going to do for the next 10 minutes, and then do it for 8 minutes, and then at the very end sort of summarize what you're having. Okay, I think that's reasonable. Obviously, organization. They point that out that they apparently see some things that are not so well organized. We try to organize. They just want it to be clear, really, basically, very. As again, no frills. I can bring software in. You can bring the TI-83 in. You can bring other pieces of software into this when it makes sense, but not just for the sake of bringing things in. Steady tempo. Too often you get too excited about talking in the beginning. You're rushing through things, and you got to try to keep a nice, easy tone for it. They like a clean screen. If you've seen some of the con videos, not all of them, some very, very good ones. A lot of times the con videos, the screen is absolutely full of figures with arrows going around and back and up and down and stuff. I like to try to do it like scroll going down even onto 2 pages, whatever I have to keep it try as open as I possibly can. And we wondered at one time whether we ought to be doing videos where they could see the faculty member as well as watch it. And they turned out that no, that's not important. They'd rather focus on what they see the pen or whatever going on the screen. So it's simpler that way. It makes it simpler to tape all of this. Okay, here's my impressions. The 100 minutes evaporates. I don't know where it goes sometimes. It just flies. Before I know it, I've got 15 minutes left to go. My own personal feeling is that they're working harder longer. I don't know, I haven't achieved that 100, I don't know, but it seems like you can tell. You're walking around, you can see. I mean, yeah, there's some downtime, sure. A couple times kids get off talking about something else. That's okay. Because 100 minutes is a long time, on the other hand, to be working. But by and large, that's my observation. I cover at least, I'm not losing anything in this. I'm not sacrificing anything by this method. You know, you think, I got to cover all this material. Well, we're covering this material, just in a different way. I can address a wider range of students, and that seems pretty clear. I can give more time to students who seem to need the time. I certainly can develop a closer rapport with the kids much earlier than I normally would, because day one, I'm out there talking to them. There's no worries about the technology failing, unlike other situations, you know. I use PowerPoint sometimes, and the clickers, sometimes they don't always work. Now, where's the technology? All done outside of class. It's all done in sealed, so You don't have to worry about anything going wrong. It's just you in class in mathematics. These are the 4 levels again. I mean, the video presents them with a definition. The quiz gives them a chance to explain it. Then I comment on it to try to make it clear what the definitions are all about, and the exercises hopefully make clearer and clearer. So you get 4 levels of kids seeing definitions, explaining definitions to me, trying to use definitions and to solve problems, computational problems, and then trying to use the definitions to solve more interesting problems. So you sort of get a 4-level experience of kids going back and back and back to the fundamentals of that particular class. And an unintended consequence, but the quiz has certainly improved attendance and punctuality. I've had no trouble with that at all this semester. Okay, I think that's about enough for me for the time being. I will come back and say something about videos in a while, but I'm afraid to talk about some things. Oh yeah, there's some websites there if anybody's interested. I can show you some of the stuff that's coming out about flip classrooms.
So I did a comparison of my 2 classes. This semester I have Calc 2 classes, and they are about the same size. I teach about the same time. One class is 8 to 10, the other class is 10 to 12. So I don't flip the whole semester. I just do that for about 4 weeks a month. Right? So for the week 1 to 4, we cover chapter 5, which is integral skills, how to do integration. If you forget what is integration, just forget about that. And chapter 6 is usually the hard part of the calculus 2. It's applications of the integrals, right? So that's a real world problems. That's usually the hard part. So I start to flip the section B and leave the section A still doing the regular lecture. So I want to see without flipping how they are, and after flipping what they are. So that's my study project like that. Because I'm the data guy, so I just collect a lot of data. So I did similar things as Ray. I do 15 minutes per class about videos, then 2 to 3 short videos. I put it on YouTube, and I also put the WMD file on Blackboard. They both have advantage and disadvantage. YouTube has advertisement on that. They don't like that. And the video is not as clean as the WMD. But many people cannot watch WMD file on their own laptop. So I just do both. If you want, you can watch that. They need to download something. And many of them want to keep the videos on their laptop that they can review in the future. So we also have entrance quiz. My entrance quiz is about 5 to 7 minutes, so it's very quick. I just pass the quiz out, then I start to track that. The quiz is either just the formula of the integral, like what's the formula introduced in the video like that. They just copy. They even allowed to bring an index tab for the quiz if they want. Or exact same example I did in the video. Or I just change the numbers from 1 to 2 to make sure they understand the formula. Then after the quiz, they start to do the group work. So 3 to 4 people to do the group work. Then I walk around, help them, and they just focus, like unlike Ray's class, in calculus level, they just focus on the solution. If the solution is correct, they're very happy. If the solution is not correct, they're very sad. So that's just like that. And actually, I pay more attention in the process, but they just care about the numbers, right? So after each, I post question by question. After each question, I always write down the detailed solution in the on the screen, because I not only want them to find a solution, but also want to teach them how to write it down, the process part. So, but they like that. They want to learn how to write down the things, and how to set up things like that. And sometimes I use collectors to make sure that they are ready to move on to the next topic. The collectors is kind of individual things. They give me some solutions. And because my collectors is the more advanced ones, that they can put in the numbers. So now collectors can put in numerical solutions. So I can design some questions fitting for the Calculus 2 level. Because in Calculus 2 level, I found if multiple choice questions, it's sometimes very hard to find a good choice, design a good choice. But with the numerical features, it's no problem at all. So, and after class, we have WebWork, which is the online homework system. So that's a major thing for them to do homework. Of course, I assign some additional homework on the book, but to be honest, I really don't know if they work on that or not. Most of them, they just don't do that. They focus more on the WebWork because that's something that will be collected and graded automatically online. So this is the background. So this is the comparison. So exam 1, this is a non-flipping class. Exam 1 and exam 2. So of course exam 2 is harder than exam 1 because the material is harder. Okay? And the flipping class. So if we compare with them, for exam 1, the average median of these two sections are about the same. Okay? This is just 1 point higher. But after flipping for exam 2, since the flipping class is higher than the non-flipping class, especially the median is 7 points higher. So I'm pretty satisfied with this result. And if we consider about the distribution of the points, right? So from here, the non-flipping class seems like the exam 2 about the applications of the integrals. All these decrease, and the fail still increase like that. So it's like everywhere it's going worse, right? But for the flipping class, the interesting part is that the 90 people get higher and the 80 people get lower. So I think that maybe flipping helps those people that who are not those gifted students, like not that good in math, but they work hard. So they flipping force them to change their study habit, and they have some extra resource to review and to prepare the test, so they do better. And also for the failed student, because we have every quiz, so they have to come and they have to learn something like that. So they might get benefit for this. So that's good.
For the people that did really well on the first exam, did they all stay in the 90 to 100 range on the second exam, or did you see that some of the really good students drop off like?
I haven't compared the real people, but I think for most of them, most of them are still in the 90s. Because they are like the students. Anyway, they learn. Even I don't teach anything, they will get 90. Of students, they can learn by themselves. So this result seems pretty positive for me. But again, I know statistics, so so this is a small example, just 30 students, yes, 30 students. It's just 4 weeks work, so it's not a large sample, so it's just give us some feedback. About the WebWork, the homework part. So for section A, if not flipping, these two classes are almost same. Actually, the flipping classes are a little lower than that. But after flipping, they get higher than that. Class. Originally, I thought that the flipping will help these people reduce the amount of time after class on the WebWork. But actually, that's wrong. I surveyed for each WebWork set. I add a question at the end, like how much time, let them record the time they spend on this. And actually, the flipping class spend more time than that. I don't know the reason, but maybe their attitude changed. They really want to figure out those hard problems. But originally, I thought that you spend 20 minutes before the class, and then you get treated back, like say 20 minutes after class on the WebWork. But that assumption is wrong. They spend more time. Of course, that may be because the WebWork in that chapter is very hard. In chapter 6, it's very time consuming. So if your attitude is positive, then you spend more time. I also did some survey on students. About 78% of students watch the video before class, and they spend about 21 minutes per class outside of class time. So my video is 15 minutes, so they watch about half times before class. And we did a paper survey about to what degree did the video help you to learn the class. And 0 means nothing, 5 means a lot. The average response is 4.06, which is good. This is Jean helped me to do some focus group that we studied five students that they taught face to face. And I'm supposed not to do those things by the human subject detection like that. So I have Jean help me to do that. And she can talk about it.
So we had actually 4 ended up showing up to the focus group interview. Dr. Fay asked students to volunteer to come, and 4 ended up coming. And it was a semi-structured group interview that lasted about an hour. And the questions were focused on the students' perceptions about the video, about being in a flipped class, and a few other topics. The transcription goes on for pages and pages and pages. I've just cut a few quotes from what they said. And this is the student's language, so it doesn't always read smoothly. But one student said, "My focus factor decreases in the lecture. The videos in classes were more interactive." She liked being able to let the information soak in on her own time rather than having to make sense of it and make use of it right away. That was a theme that came up across the students that participated. These students, by the way, none of them were math majors. 2 of them were engineering majors, 2 were biochem majors. And one of the students who identified herself as a weak student mathematically felt that the videos were a stress-free visual method. Again, student language here. She said when Dr. X does it in class, you're worried about getting the visual picture of it. And you're worried about, do I understand it? Is this confusing? So being able to watch the video in her own dorm room at her own pace was much less stressful for her. She already had anxiety about performing well in mathematics class. She also said that she liked the videos because when she went to do the group work, she felt she could contribute more. Before that, when students would just break up into groups when she didn't have time to watch the videos, she felt like she could never bring anything to the table. But by spending time watching the videos ahead of time, she felt like she was a meaningful participant in the groups. I like this quote too. It's long, sorry, but it's good. When you're in class, you can shake your head and you know every step. And any of us who've taught math and maybe similar fields, you get this when you say, "Does everybody understand it?" And they're like, just get me out the door. or I'm too embarrassed to say I don't understand. And then when you go back by yourself, it's always a very different story because you have no guide to help you. Students routinely come up to us and say, "I got it when you did it, but then when I tried to do it, I don't get it anymore." And she said that watching with the videos and doing the examples with it, and these students, 3 out of the 4, actually rewatched the videos several times and worked the examples as Dr. X worked them. She thought it was more of a self-tester. Watching the videos and working through them gave her a sense that she really understood it and boosted her confidence. And it gave her the sense, oh yeah, I do understand the concept. And she felt like it was a lot more efficient to be able to do that on her own. We asked them to talk about what they did like about the videos. No one had anything negative to say about the videos, except that they didn't like it when their group members didn't watch it, because then they felt like they had to spend time catching up their group members. And one of the gentlemen in the group said he wishes there were more, but he knows that Dr. X said they take a long time to make them, so he understood that there couldn't be a lot of videos. But this was the same student who watched every video before every class, and then before an exam he watched the videos 2 to 3 times more. So he wanted more videos outside of class. He was also quick to point out that while we had been spending a lot of time in the interview talking about the videos, that really the most beneficial part of flipping was what was happening in class. He said before he had Dr. X's videos, he watched the Khan Academy videos anyways. That's how he got through Calc 1, he said. But he also said he liked the fact that it was his own professor on the video, because I guess Dr. X has some famous sayings, like you got to kill the beast when you solve a problem. And so he would say things that he said in class on the video, and they liked that connection. And also because they learned how to do problems the way that Dr. X did them, and they thought that that was important. And again, they liked the fact that he was right there in class with them, that when something went wrong, he was able to answer their questions and support them. A theme across all the students really, but I picked this quote from one student in particular, was they felt more free to ask questions. I think a lot of times in math class, students think they're the only ones that aren't getting it, and so they don't want to hold up the class. So this student said he felt more free to ask questions because there was more of less of a time constraint. I would not ask questions when Dr. X was just lecturing. So when Dr. X was doing just a lecture, in the non-flip class, they would not stop him if they didn't understand. They said they didn't want to have him rewind the lecture just for them, because they thought it was just them that needed the help. So this student was sort of self-talk. All right, I don't understand what just happened there, but I'm sure Dr. X will explain it later, and didn't want to hold up the whole class. So again, this is the same student who saw the benefit of a different use of class time, and the fact that there was more interaction and more ability to ask questions. Okay, again, there's pages and pages of these transcripts, all extremely positive about the videos. And what surprised me about the videos in particular, because we've had a lot of discussions in the math department about how professional the videos have to be, what sort of animation should we be putting in there. And the students in this group said, keep it simple. They wanted to have the professor's voice. They wanted to have, they liked that. They liked being able to have the professor explain it one way in the video and hear that reinforcement in class. But they didn't want a lot of distractions. They liked the simple screen with writing and the professor talking. So that's reassuring to us, because we don't think we can pull off Hollywood even if we tried. But it looks like the students don't want that either, at least from this group. So.
Is there a way to get those comments electronically?
I can,
Transcripts?
I'm sure we went through human subjects, so I would clean it up and I'd be happy to send those comments out.
The provost wants to get a sense of this is all worth it.
Sure.
So.
It's it's an N of 4.
Yeah, I understand.
But
Something.
they didn't receive any benefits from saying this stuff. They could have told me that they hated it and it wouldn't have mattered.
I haven't seen those comments.
No.
This is my first time, so. All right, so I also did a paper survey, like, to the whole class, like what do you like, what do you don't like. So the benefits is like this, very similar to race response. So the challenges were if they forget to watch the video, there are always some people haven't watched the video. Then they're dead in the class. They don't know things. So I found that sometimes I have to review before the class. I will write down the formula to that, and at least they know what's going on. And they said there are no chance to ask questions when watching the video. Sometimes if it's not clear, then they don't have a chance. That's a disadvantage. And about the technology, like there are always some problems with the technology, the format, the volume is low. I don't know why, because the record things. There are many technology things. And the length of the video sometimes is too long. If I record too long, it's too long. So, yes.
I got that comment about frustrations because they couldn't follow the video. And I got it too often in the survey. So we're going to have a chat today before class. They do have a chance to ask questions about the video, and that's called office hours. Coming down and see. I mean, really.
It's when you wait till the last minute to watch the video.
They got to bring something to the table in this whole venture. I mean, at least my class for sure, sophomores and juniors. And that's no excuse. And so I'm hoping that we get a little better results on that, because this is not just more lecturing. Well, I'll come and get what I can out of the video, and then they'll teach me the rest anyway. And I really want them to do that and come see me if they don't understand the video.
Okay, I'm going to put in a quick plug. We also, at universities, purchase WebEx, where WebEx will allow you to actually do virtual office hours, so students can't come in and see you, but they have a question. You can actually, if you have the tablet, you can actually walk them through using WebEx, so that's an option.
We're doing a training on May 4th.
It's a sales pitch.
I think so. I think that's
Just me.
Hey, why did you guys use two different technologies? You used Echo, you used...
I use Smart Notes.
Okay.
Smart Notes. Yeah, the Symposium has a feature of videos, because at that time I don't have a tablet, and I want to pull up the TID9, the Maple things in the videos, so I use that.
I use that. We all use something.
Yeah.
I think Ben was using Camtasia.
Okay, yeah, sure.
So we haven't worked on that. So I just the last part. This is what we're going to do next. We're going to try flipping for count 1 in 4 out of 8 classes. So in the fall, we're going to have all full-time people teaching calculus, hopefully. And in 4 of those, we're going to try to flip, 4 we're not. We're going to work together. So the whole department is generating the videos, the questions, and things like that. And that's what we're trying to do right now. So we're going to try to create a video library. And right now, I think we're leaning towards one person doing one section, somebody doing a different section. So you won't always have your professor doing the video. We're trying to also get a TWOS grant to study this. So we're going to try to assess what's going on in the 4 flip classes versus the non-4 flip classes. The development is, we're sort of focused on the video now, but there's a lot more to it than the video. We need to figure out good problem sets, and in Calc 1 we do some labs too. And the type of discussion questions are more like the clicker questions, which we want to put in there to sort of break up the, as Ray was saying, you don't want to do the same thing for too long. You want to have a little bit of different experience. So we're going to have about half of the students. We're going to do a study and see how that works. We're going to, if all this is good, then we're going to have a website. So part of the grant is in the fall we'll flip half of them, and we'll do some assessment of it. In the spring, I already have 3 people that says they're up for flipping it again, and we'll do some more assessment. In the summer, we'll decide whether this is really what we want to do. And if we really want to do it, when the department says, yeah, I think that's what we're going to flip them all. Yeah.
How, for all the different Calc 1 or Calc 2 sections that you have, is every professor teaching the same thing at the same time? So what I noticed is, like, for biology, especially for our 2nd semester course, I mean, we're all over the place. I'm teaching and someone else is teaching, and we're not even, I mean, we have the same syllabus, but if I fall behind, you know, he goes ahead, and so,
if you're
it would be hard to, like, compare and contrast 2 different professors. And so I wonder how that would happen. You know?
In calculus, you're not that far different in topics like that. And also part of this, which we didn't talk about, which Ray mentioned, was we're going through and trying to find what we're calling the nuggets for every section.
Yeah.
So we're trying to uniformly pick in section 4.1, what is the main thing you want to get across? And so we've had discussions about that. Everybody says, this is what I want to get across. And we put up, these are what 8 people say they want to get across. And we decide, okay, among those things, what is it we really want to get across? So before we do the videos, we're going to have sort of lined up, at least for Calc 1, exactly one thing that everybody's got to get across.
It's a very concerted effort, basically.
Yeah. So we're all working together on it. It's not just one person doing a class. It's everybody in the department pretty much is working on what we're going to do in this class.
Yeah, I think that's been a benefit of what we've done in our conversations about flipping. We've really come together as a department. Even people who have no interest in flipping, they still want to come together and talk about teaching. And so we've been meeting on a regular basis to do just that. And so even if the flipping fails, together as a department, I think we have all spent a lot more time talking about our pedagogy, and that's been really good for all of us.
Yeah, I'm not sure if it's going to fail in the absolute sense of the term. It may not continue exactly the way we have it, but there's too many apparent good things happening, not for there to be some good path to follow. We may not be following right now, but I mean, it just feels, I mean, at a certain level, you teach, you feel it. It just feels like this is the way.
I agree.
Yeah,
I know for us, for what I've seen in our department, is that, and I think maybe it's just bio, because bio is just, it's so diverse, and so, you know, I'm a microbiologist, and my colleague teaching 123 is a neurobiologist. I mean, we have nothing in common, you know, other than we're biologists. And so we look at it completely differently. I mean, it's completely differently. So I'll focus on certain things, and he'll focus on certain things, and I'll take a longer time with this. And so it's hard to come up with a very
Our original discussion was to look at Calc 1 within the department before we even did flipping, and to figure out where we all were in teaching it. And I think what came out of it, surprisingly to me, was that we're not here. We're pretty much here. We pretty much all think this is what you should be doing. And I think that was a surprise to, maybe we're not quite the same emphasis on different things, but we're pretty close on what is the important topics to do.
And I mean, I think that makes a big difference for the students too, right? Because if they take, say, CS 114 intro to programming, and then they go to 115 and they have a very different experience in 114, you're setting some students for failure once they get to 115. need, or biology, or chemistry, or mathematics. So by having those core learning outcomes, like you say, they're going to get addressed no matter which section, who's teaching it. You're going to hopefully minimize that issue.
I think that's it. So we'll take questions.
How would you encourage other departments to follow along? I think it's a great path. I'd love to see other departments sort of.
I think we start with your introductory course. You know, have a discussion along curriculum first of all, see what it is you want to teach. See if there's some interest. We got to see if this. You know, I used to do some consulting in high schools. Go on to try to work with high school programs. The first question I'd ask the superintendent was, is there any interest in really doing some reform here or not? Because if there wasn't, you can't do it. I mean, you got to engage in your partners. And you don't need everybody involved, but if we could get 2 or 3 people in an 8-person department of high schools to do something, that was enough. So you'd hope to get 2 or 3 people who would be take this one. Well, that's all you need. As John said, there's a lot of half the department's not going to fill. But that's why I start with a big course, not some esoteric upper level course, but start with a basic certain. Yeah, so as well.
One of the things that I teach a statistics course, and it's to graduate students. And most of our students, we think, are supposed to be coming in at the same level. And what I've been doing over the years is, you know, kind of assessing is everybody in the same place? And if they're not, then I have to drop back and teach some kind of earlier material. So one of the things I think is going to be a big advantage with the video capture, it's not so much about flipping the classroom thing, but it could be, is the idea of having videotapes of material that you build on. So the basic building blocks, and then when I go in and work, it's more, I'm just kind of going to the next level with the material. And I can say, well, you know, are you familiar with ANOVA? Are you familiar with non-parametric? If you want, there's a video if you want to watch this. And so I think it's that kind of idea where I feel many times I'm kind of slipping back and going backwards, you know, 2 steps forward, 1 step back. And this might be a nice way to do this. It's kind of building that library of materials that you can build on and rely on.
I think that's going to be true when we do the videos for, so we've already done some videos for some of the calculus sections. And there'll be some part where, you know, I know that there are times when half my class doesn't know one topic, the rest of the other half does. So I developed 2 videos for that section. So here, if you don't remember how to decompose functions, whatever that is, here, go watch this video. Because you should have seen that in pre-calculus, but if you don't remember, go watch it. So maybe it will even benefit those students that sort of on-time delivery of what they need.
My question was about videos. Can you talk a little bit about how difficult that hurdle was to create videos, finding the technology, learning it, to actually get those videos out there?
Oh, there's lots of funny stories about it.
Yeah.
You know, getting started, you got to go to your room at home, close the door, take the telephone off the hook, make sure the cat's not around, and things beeping in and off. I mean, at first it was frustrating to get used to it. Echo is good. I really enjoy using Echo. I mean, I wish there was a perfect system where you could do editing much more easily. You can't do insertions.
Yep.
All you can do with Echo is you can do some splicing afterwards, cut things out. But if you get better at it. It takes me about an hour and a half. I mean, for the,
To do a 15-minute video?
about a 10 to 12 minute video. I mean, but that's doing everything. That's from the time you plug it in to the time you get it done. I can't do it in one. It's a 10-minute swing. Now, John's got another way of doing it. It's a 10-minute swing. Probably until the time I finally get it published. Yeah, it's about an hour.
And you use the personal capture kind of thing?
Yeah, Echo. Yeah, it's downloaded my
Got it. Yep.
tablet, and it publishes
Right.
everything to Blackboard, to my Blackboard account. So I have a thing called videos there. The kids log in, plug it right up.
And you have a tablet PC where you can write right on
That's
it.
what I do. I have it right on that. Just one of the tablet PC, sure. Yeah. And I used to start and you make a mistake in the first 3 seconds. You know, oh crap. You know, start over again. Then you get about a minute into it, another mistake. Now I find it, for me, what works best for me is I don't chart this. I don't script it exactly, but I know the definition I want to get. I got an idea. The example works, the one I want to get. But I have to write the example down. I sometimes forget mid-example. What the hell's going here? So I got to have a picture of that. But what I do now is once I get this thing off the ground, the first minute or so, I just push through. If I make mistakes, I don't care. Because I think I patterned myself to go through it once and just do it. And then I remember all the mistakes. I sometimes print it out, because if I have it on the tablet, I'll print it out the hard copy, go back and edit that and say, I don't want to do that again. Watch out for here. And then usually by the 3rd time I'm doing it, I got it. some perverse way, I sort of enjoy it. I mean, I guess it's but people are pointing out it's not the video that's the main thing here. I think it's the problems.
Oh, the work problems?
The work problems.
Oh,
No, I think that's the issue in the classroom. Getting the right kind of problems to ask the kids that are going to engage in, and finding complementary homework problems. I mean, that balance. I think that's where the action. The video is you're priming the pump. I think, and that's good. But I mean, I used to go, if I made an erasure or something, I'd crack the video and backstart again. Not now. It happens in class. I write the wrong thing down. I just erase it. As long as it's not too many of them, so it's distracting. And just keep moving.
Yeah.
So.
Do you think it has caused more of an emphasis for them on process? You had mentioned the process versus getting the right answer, but I'm wondering if over time, would you see that they'd be more interested in, just because they're doing so many problems and really going through the process, less emphasis on the right answer, and for you as well as for them? I don't know if that's how you teach already, but I'm just, we were at an Apple briefing down in Philadelphia, and one of the people there was a former chemistry professor, and he was really sharing his story about how he had come around from grading people wrong because they got the wrong answer because of one input was wrong, and how he realized it's really the process that was important. Do you think that's going to influence for the students?
Well, in my course, it's all process. So I hope it influences positively. I mean, they're getting more assisted experience in my class than they used to get. That's the big deal. I mean, more hands-on. And I think that's got to help.
In calculus, I see that we're going to be they're going to be working on the problems, and then towards the end of class, they're going to throw the solutions up on the board so we can all look at them. And at that point, we'll be able to discuss process. Not only process what you did, but if I have a table over there that did something different, my hope is to throw both those things up and we can compare and contrast.
Right.
So emphasis on how you do it is going to be important.
That's what the Provost grant really is for too, the iPad. So our vision is to have every pair of students, maybe every group of 3 to have an iPad. There'll be working solutions in class, and then we'll have Apple TV working with multiple projection units, and we can pull up solutions and strategies.
Wow. And you're using smart boards for around the classroom, is that correct?
Interactive.
Just projections with the from the iPads. So not much.
Something else. As far as your definitions in the video, how do you feel that it's different from just reading the textbook? I mean, is it so different that you need the video for that? Can they just read the textbook?
I mean, Gene's more of an expert in this, but I mean, they told me flat out in the service, several kids that we won't read.
Yeah.
Not math books. Math books aren't written to be read, really. They aren't.
No.
There's boxes that students go to for the definition of the theorem, and then they might follow a worked example, but they're not written really to be read. At least math textbooks.
Yeah.
The authors think they are, but the students don't. So.
But then how are you explaining the definition different than what's written in a book anyway? I mean, the definition, I'm thinking of a definition in biology terms, like, a mammal is something that does this, this, and this, or is this, this, and that. I mean, I don't think I can, in a lecture, and I hate lecturing because of this, I'm saying something that's very similar to the textbook. I don't see how that's benefiting anybody.
Yeah.
I didn't say, and I don't know what biology specifics you teach, but some of the research on visuals and auditory learning is that it's more powerful to have both of those senses.
Yes.
So that if you were talking and narrating, but you had visual images of what you're talking about, it's a little different in math, where you,
But it's a blank screen with a book. It's loaded with text and examples and pictures, and we start with a blank screen, and you're right, they're hearing us say it as we're writing it. So their focus is exactly where it needs to
I guess
be.
the other thing I'm thinking, though, is just, in talking with colleagues that are doing similar things, is that you gotta save my time. I mean, it's great that you're spending an hour doing that, but honestly, I don't have an hour to do for every, an extra hour for every class. I have 2 young kids at home that I have to, and so.
So we're kind of hoping to mitigate that by doing the whole group.
Absolutely, absolutely. But just at some point, it's like, all right, look, you're at college, you've got to be able to read a book. I'm sorry, that's part of it.
What was the video that came out a couple of years ago? Didn't Walt show it in one of the presentations about how kids really act these days? I mean,
oh, no, it's awful. I mean, it's obvious to me that they're not reading, I know that, but, it's
Well, they're reading, but they're reading very differently than the way we read.
Exactly.
They're reading on the internet. So it's a kind of information, it's a technology literacy
Mhm.
that I think we have to teach them nowadays, rather than saying, here's the book, read the book.
Yeah.
The truth is they're not going to do it.
Right.
So why don't we give them the skills to be able to surf the web and find
Yeah.
information that's accurate, that's
Yeah.
helpful?
Yeah,
And
that's
I would
smart.
rather spend my time doing that rather than saying, just read the book, which they're not going to do.
Right.